Hi guys, this is Miss Eisencraft and I'm here to go over changing quadratic equations from standard form to factored form. Oftentimes it's just called factoring. So last week we had factored form, which were in the two binomials, and we were multiplying them out using the box method, and then we would simplify them and they would get to standard. So we're going to go backwards. So for standard form, the four terms inside the box got simplified to the three terms. So let's just think of what we're after when we get to factored form. Factored form is going to look like this, right? And these are going to be two binomials. So using the box method, and this is our model, we know that this corner here was made by taking the x times the x, and we get x squared. And this last corner here, bottom right, is this term here. The 6x is not in the box. It is a combination of these two right here. So this is where a little puzzle comes in, because we know if we were to unmultiply it or factor it, that x times x makes x squared. And then here, we need to think of two numbers that multiply to 8. And you might be thinking that's easy. But we also need those two numbers when they go inside here with the x to combine up and add up to 6x. So there's this little puzzle, sometimes referred to as Timba, or the puzzle is drawn using an X. And where Timba comes from is we are looking for two numbers that multiply to make 8 and add to make 6. And Timba stands for top, multiply, bottom, add. Top, multiply, bottom, add. So this is just a little structure to help you figure out what two terms go inside here and then go outside here so we can finish factoring. So factors of 8, we want, whole number or integers that multiply to 8. 1 times 8. The next one is 2 times 4. And we need to choose the pair that not only multiply to 8, but also add up to 6. And so that is the 2 and the 4. So I'm going to put them here, and you can always check that this is true. Does 2 times 4 make 8? Yes. Does 2 plus 4 make 6? So this fits both of the criteria. So that would mean you can work out backwards. You can say this is a 2, this is a 4, and it's okay if you have them in opposite spots. So that would have made this a 2x and a 4x, which is where that 6x came from. Always make sure your box would make this if it was simplified. So now we can be sure that factoring this, the two binomials that multiply to make this are x plus 2 because it's positive, and x plus 4. So x plus 2 times x plus 4. Okay, this is the factored form. And you can double check and make sure it all works. All right, next one. We have x squared minus 3x minus 18. So in standard form, we know that the x squared came from multiplying x times x, and it's in this corner. And then this term here is in this bottom right corner. These two terms combine to make negative 3x. So we are, in fact, trying to figure out what two numbers multiply to make negative 18, but then they're going to add up when they're with their x's to make negative 3x. So this is where I'm going to use the Timba puzzle. I need two numbers that multiply to make negative 18, but add up to make negative 3. Now, when you get negatives going in here, it gets a little bit more confusing. So I just like to take the absolute value when I think of the factors. But when you multiply two numbers and they're going to add up, when you multiply two numbers and they're going to be negative, we know one has to be positive and one has to be negative. So if I write them out, 1 times, just pretend, just take the absolute value. And then one of these in each pair has to be negative. We can decide that later. But do any of these pairs of numbers, they all multiply to 18, but do any of them have a possibility of combining to make a -3 if one of them is negative? So here, if you made one of these negative, no. If you made this negative, it would make 7, or this negative would make -7. But it looks like if you made the 3 negative, it would make a +3 when you combine them, added, or if you put a negative with the 6, it would combine to make a -3. So this looks like our winner, our pair of numbers. We need them to multiply to -18, but add to -3. So it does matter which one has the negative. When you combine them, you need to end up with a negative, so the 6 needs to be negative. Multiplies to -18, adds up to -3. You're doing two different operations here. So these numbers here, the 3 and the -6, are actually the numbers outside of the box that were multiplied. And you could flip them if you want, right? They multiply to make -18, and then they make, the 3x and the -6x, that combines to make that -3x, or that middle term right there. So we have y equals x plus 3 times x minus 6. Okay, next one. All right, you're going to start to see some patterns of how this works as we go a little bit faster. So when you're in standard form and you're using the box method, the first term, goes in the top left corner. The last term goes in the bottom right. And then to figure this out, right, -15x, we need to ask ourselves, what are two numbers that multiply to make this number? Because we're looking for two numbers to multiply to make 50, but they need to add up to this, -15. So sometimes you can jump right to it. So this is a little bit weird, like you don't need to go through 1 times 50, 2 times 25. You can. 3 doesn't go into 54. Okay, so I'm going to jump right to 5 times 10 because I know that combination. Now, we need it to add up to -15. Remember, two negatives can multiply to make a positive, but when you add two negatives, they just make a negative. So we have -5 and a -10. So these numbers here, let me put the x's in there, are outside the box. They're the factors that were outside, and then they multiplied out to make a -5x, a -10x, which combines to that -15. I'm just making sure that's right. And two negatives, when you multiply, make a positive. Okay. So the factored form is x minus 5 times x minus 10. A little weird to have the two numbers multiply to make a positive, but add to make a negative. Those have to be double negative. Okay, let's keep rocking and rolling. Here we go. Next one. Here's standard form. So I'm going to take the first term and put it right here. The last term, put it right here. And so to find these two terms, or these two factors out here, I need to ask myself, what are two numbers that multiply to make 24, multiply to make the last term or the C term, but add up to make 10. Now this is positive and this is positive, so they have to both be positive. So 1 times 24, 2 times 12, because at first this seems like, hey, promising, because if one of those was negative, it would make 10, but you can't have one of them be negative, because when they multiply, it has to be positive. Okay, so 3 times 8, no, 4 times 6. And if you have trouble finding your factors, you can just use a calculator and just start at 1 and divide. And we're only looking for, integers, so no decimals. 4 times 6. So 4 times 6 makes 24, and 4 plus 6 makes 10. So these numbers here are your factors, or the numbers that go outside. And again, it doesn't matter where. And just make sure that, does the 4x and the 6x make that middle term? Yeah, it does. Okay, so we were breaking it apart, factoring. So it's a little bit hard because this was, combined. So you have to figure out what number was combined, what two numbers were combined to make 10, but multiplied to make 24. So again, we'll get y equals x plus 4 times x plus 6, both positive. Okay. Next one, x squared plus 2x minus 15. The x squared is going to go here, negative 15. Two numbers that multiply, boom, to negative 15. A little weird when it's a negative, but they have to combine or add up to a positive 2. So 1 times 15, that does not look promising at all, even if you make one of them negative. 2 does not go into 15. How about 3 times 5? Okay, if one of them was negative, when you multiply, that would make negative 15, and which one would need to be negative to add to make positive 2? So I just put the 3 and the 5 in there. And I know that I need the bigger number to be positive. So, because when I add them, I need the absolute value. I need the 5 to be bigger. Okay. Okie dokie. So then these are my factors, negative 3 and 5. Make sure it works. Negative 3x and a 5x combined to make 2x. That works. Y equals x minus 3 times x plus 5. The whole goal is to get from here to here. It's a lot of work, but you start to kind of train your brain of what's undoing standard form. Last one, we're going to put x squared here. The 8's in the bottom right corner, and we know that these two had to combine to make a negative 9x. So this is where Timba comes in. We need two numbers to multiply to make the 8, because that's these two. They have to multiply to make 8, but they have to add up. The coefficients have to add up to make negative 9. So whenever you have to have two numbers multiply to make a positive, but add to make a negative, they have to be double negative. So 1 times 8, just if you think of the factors as their absolute value at first, that's a little easier for me. They both have to be negative, though, because the only way to have two numbers multiply to make a positive and add up to make a negative is have them double negative. It looks like negative 1 plus negative 8 will make negative 9. And when you multiply them, they make positive 8. When you add them, they make negative 9. So those are our factors. Let me get the x's out there. Negative 1, negative 8. And then you have negative 1x, negative 8x. Oh my gosh, that was supposed to be purple. Okay. All good, all good. So then we have y equals x minus 1 times x minus 8. Right. So good luck. Delta Math, you'll be doing some of the boxes and some of the puzzles. Have a lot of fun.